everyone, welcome back to Spark Optimization series. This is episode 3 and today we are tackling a very critical topic which is spill in Apache Spark. If you have ever wondered why your Spark job is slow despite having tons of resources, spill might be the culprit. By the end of this video, you will know what spill is and why it happens, how to spot it in the Spark UI, practical techniques to avoid spill and improve your job performance. We'll go hands-on with real-world examples and optimization techniques, so grab a cup of coffee and let's get started. Let's start with the basics. What is a spill? Let's understand this concept with a simple diagram flow. So let's say this gray box is a Spark cluster with two nodes. This is node 1 and this is node 2. We're gonna simulate the spill problem in node 1. So let's say in node 1 we have some amount of memory and some amount of disk. Spark is designed to perform computations in memory for lightning fast performance, but memory isn't infinite, right? When Spark runs out of memory during operations like shuffle, joins, or aggregations, it offloads the intermediate data to disk, and this process is called a spill. Think of it like this. Imagine you are organizing your wardrobe, but there's not enough space. You take out clothes and put them in a temporary box. That's spill. While the box helps you temporarily, accessing items from it is much slower than grabbing them directly from the wardrobe. In Spark, this translates to disk I/O, which is orders of magnitude slower than memory operations. Spill typically happens during these operations. Shuffles when data is redistributed across partitions, joins especially when both datasets are large, aggregations when intermediate results grow beyond memory limits. Now, how do you know if a spill is happening? Let's explore. In order to identify a spill, Spark UI is your best friend. Here I am using the Spark UI simulator provided by Databricks. They have the experiment called spill where we can actually go through the properties and configurations on the UI which are important to identify the spill. It was a bit hard for me to identify the big data set which is also skewed to reproduce the problem, so I just thought to use their predefined experiment. So this is the notebook, and in order to identify the spill, we gonna go to Spark UI, and under Spark UI, I am gonna go to the skewed join because join is actually causing the spill. Now, if I go inside this stage and try to check one of the stage in detail, I'm gonna see the all associated task. So if you see this stage has 825 tasks, and for each task we can check the spill if it is happening or not. So if you see these two columns, which means spill is happening. Now if I go down, I can see 2 GB spill memory and 949.4 MB spill to disk. So what does this mean? Of course, there is a spill in your job, that is for sure. Now, what does these two mean? So they both are actually same. So spill memory is like how much data is actually being spilled from memory to disk. So this is the actual amount of data, which in this case is 2 GB. And spill disk means how much data is actually being written to disk, which is in this case close to 1 GB. It's gonna be less always because this number will be less always because this is the data which is written on the disk, which is for sure gonna be less because Spark gonna write the compressed data on the disk, and this one is the actual data that is being spilled from memory to disk as part of the transformation. So if you see these two columns in your job in your job performance job execution UI, you can say there is a spill in the job. Now if I go back and let you explain what is happening. So this is just some things that they are trying to explain, what type of data they have a skew, of course, and this is the code which is actually causing the spill. So if we see this city ID, and this join is actually causing the spill. I hope you understand how to get an idea and how to know where spill is happening, how spill is happening, and how can you identify it. To know how we can identify the spill using Spark UI. But why does spill happen? So here are the key reasons why spill might happen. So first one is insufficient memory. So the executor memory is too small for the dataset. Of course, you don't have enough memory, so Spark gonna spill it off to disk. Another reason could be large partitions. If partitions are too big, memory overflow occurs. Another one is inefficient joins, joining large datasets without optimization. This is a very typical example of broadcast join. So if you have one dataset as large and another one is very small, then you should do the broadcast join, avoiding the spill. Another one could be poor configurations. Default Spark configuration might not suit your workload. So Spark come with optimized configuration predefined, but if you have a big workload running, you might think of actually going through the Spark configuration and tuning them a bit. We already talked about what is a spell, how you can identify it, where you can see it in the Spark UI, and what may cause the spill. Now, there is no hard and fast rule to fix the spill actually, and spill isn't a problem that you can eliminate fully. It's just something that you can optimize and get a more performant output from your jobs. You can do any of these three things, or maybe all three of them. Increase shuffle partitions, divide data into smaller partitions. So you can increase the shuffle partition so you have less data on one partition, and Spark can easily work within that partition's available memory. Second is broadcast join. As I said before, if you have a small data set on one side, always do broadcast join. So what Spark gonna do is broadcast that small data set on all the partitions, and that's how the Spark would avoid the shuffling, and then it does not need more memory to process the join, right? So it's gonna be no spill eventually. Another thing that you can do is tune memory settings, allocate more memory or adjust memory fraction. So it is also very important to have a good cluster in place when you are working with big data structures, right? So if you have big data, then it is very important that you have enough memory to work with that data. So you may need 1 or 2 GBs of data, memory, or you may also need 50 GBs of memory to process a task. That's not a surprise. If you have big data and you want to perform some task, then you need more memory. But you should also keep in consideration that you are not wasting the memory, which means you are not paying for the memory which is not being used. Or if you can even optimize and do this that 50 GB of work in 20 GBs of memory, so that should also be taken into consideration. So avoiding spill or making it less vulnerable to your job is actually a practice that you have to do based on your use case. There is no hard and fast rule to avoid a spill, but if you get an spill, then you can work on either of these 3 points and try to make your job work more efficiently. I also like to talk about some best practices to avoid a spill in your Spark jobs. We actually already talked about these techniques, but just to summarize what you can do and keep in your mind when actually thinking about a spill. The first thing that you can do is optimize partitioning. Use repartition or coalesce wisely. Use broadcast join whenever possible. When one data set is small, always broadcast it. Monitor Spark UI. Always check spill metrics to identify issue before actually going for the solution. Tune Spark configuration. Adjust spark.sql.shuffle.partitions and executor memory as needed. By actually keeping a note of these properties, you can eliminate the spill problem or actually decrease the amount of spill happening and make your job work more efficiently. That's it for today. We have covered everything you need to know about a spill, what it is, how to identify it, and how to optimize your jobs to avoid it. In the next episode, we will tackle shuffle optimization, another critical performance topic. Don't forget to like, share, and subscribe. See you in the next video. Have a good day.